Okay, YouTube, in this video we're going to explore the concept of an inverse function, and we're going to start by actually taking a look at a situation that would describe what we would consider to be two inverse functions and talk about how they're related to one another. So we say here are two functions that describe situations related to the price of a computer X. Okay, and so we would say maybe the cost function here is just some cost as a function of X, where X is the price. But basically what you can see here in this first situation is like price minus $300, whereas in the second situation we have the total cost as the price plus $300. And so the idea here is that these two functions kind of undo one another. If you were to take 300 off of something and then put 300 back onto something, you'd somewhat return to your original cost. So we would basically say that these two functions, the two functions here, how are they related? Are opposites of one another, okay? And we're not going to use opposite in the mathematical sense where we would just say one's the negative of the other one, but we say they are opposites and inverses of one another. So what they do is they undo one another is kind of the idea behind them. So if they do undo one another, what we're going to do is we're going to consider their composition here. And remember that a composition is this idea that I could plug one rule into the other one. And so in this case we have a rule which is g of x here that we can plug into f of x, where g of x is saying take your price and add on $300 to it, while at the same time f, its rule is saying no, take that and subtract $300 off of that. So what we're going to look at here is we say f of x, which is this x minus 300. What we're going to do is replace that with g of x. So we have our f of g of x. This is our composition of these functions. And remember that we're plugging g of x into f of x, which is given by this rule, x minus 300. So into our function here, we plugged in g of x for our x, and we get g of x minus 300. But then we do this other substitution where we say, well, I know what the rule for g of x is. The rule for g of x here is x plus 300. So x plus 300 minus 300, what we see here is that this adding on a 300 and then the immediate canceling that off, removing that, you get left with just x, which if we wanted to say it this way is really just the input value for a function here, f. And so basically what happened was we plugged x into f and then we plugged x into g and then we plugged g of x into f and we got sent back to the original x value. So we would say that any situation where I plug one function into another function, like we can see here, we say if the changes made by a function g of x are undone by the changes made by a function f of x, so we plug g of x into f of x and f of x undoes it, then we're going to end up with x. And you know what, when we undo things the other way, say we had plugged f of x into g of x, that is subtract off 300 and then add 300 back onto the cost, you would get back to the initial cost or the initial input value. So the definition really of inverse functions is that we can see that one undoes the other one. And as a consequence of this, we could say that, two inverse functions, let's look at the definition here, that undo one another here. We say two inverse functions. Let's take a look at notation first here. We say that two functions such as f and g are inverses of one another. So we saw that f of x was this price minus 300 and g of x is the price plus 300. We say, though, that since g of x is the inverse of the function f of x in this last example, then we'd write the functions also as follows. So what you're going to see here is, excuse me, f of x, which is the same f of x you see here. But what you see here, instead of g of x, since g of x is the inverse of f of x, the undoer of f of x, we often write it this way, where this is a -1 and it's not an exponent. So we say f inverse of x, and that is exactly how we would read this. We say f inverse of x is this function here, which its only job is to undo f of x. So the definition of inverse functions are just these here. We say let f and g be two functions such that when I plug g of x into f of x, I get sent back to the original input for every x in the domain of g. And likewise, if we were to plug f of x into g of x, we would just end up with the original input here, x, for every x in the domain of f. So we say the function g is the inverse of the function f here if they undo one another, and you just get left with this input here, x. And we denote it by f inverse, and that's how we'll read that, okay? So f of g of x, remember, is x. We could say also then likewise, f of f inverse of x is always going to be x. And f inverse of f of x is always x. And this is just, the whole point of inverse functions is that they undo one another, and you get left with the inner stuff that you were looking for in the first place. So we say the domain of f is equal to the range of f inverse and vice versa. Essentially what this means is our original function here, f, has domain and range. And in the next video we're going to see this a little bit better. But we say f inverse of x, and I'll just put a colon here. But we say that the domain of f is equal to the range of f inverse and vice versa. So basically, the domain of f here is the range of f inverse, and the range of f is the domain of f inverse. And like I said, we'll see this a little bit more in the next video. So all I want to do in this first video really here is to define that inverse functions undo one another, especially when you compose them together, and also that I wanted to show that we could prove two functions either are or are not inverses of one another. So when I look at this example here, it says show that each function is the inverse of the other. We have f and we have g, and they may or may not be inverses, but I know that if they are inverses, then if I do this composition here, f of g of x, they'll undo one another. And I could also say g of f of x would also be x. So the choice is, here, to either plug f into g or g into f. And I'll tell you what, plugging f into g here, you're going to have to plug in, an expression into a fraction. I'd rather plug the fraction here all in for this x here. So what we're going to do is we're going to find f of g of x. And f of x is this 4 times our input minus 7, where we're plugging in g of x. So g of x, which is this fractional quantity here, I'm going to put parentheses around all this, and insert g of x in here, do our substitution, x plus 7 all over 4. The nice thing about this is these 4's here just cancel out, and we get left with x plus 7 in the parentheses, and then this negative 7 on the outside. But those 7's cancel out, and look what we found out. We found out that the composition f of g of x comes out to be x. So this, by definition of inverse functions, must be a set of inverse functions here. So we could also call g of x the same thing as f inverse of x. It's the f killer. Okay, it undoes the f function. Cheers.